engine cooling system! We need backup down here now!
Picture the largest moving object ever built by human hands. A single container ship today can stretch longer than 4 football fields laid end to end. It can carry more cargo than 20,000 trucks. It can be worth over $100 million, loaded with billions of dollars of goods bound for ports on the other side of the planet. Now guess how many people it takes to run it. Not 200, not 50, not even 20. On many of the largest cargo ships in the world today, the entire crew, the people responsible for navigating, maintaining, and operating this floating skyscraper across open ocean, numbers somewhere between 13 and 22. That's it. To put that in perspective, a mid-sized office building has more people in it on a slow Tuesday than it takes to run a 900-foot ship across the Pacific. So here's the real question. How did we get here? How did an industry that once needed hundreds of sailors per voyage shrink its crews down to a skeleton team, while the ships themselves got bigger, faster, and more complex than ever? The answer isn't just technology. The real story is stranger, more calculated, and more consequential than that. And it starts with understanding what a ship's crew actually used to do, and why almost none of that work looks the same anymore. Let's go back about a century. In the early 1900s, a cargo ship crossing the Atlantic might carry 80, 100, sometimes more than 150 crew members. And they weren't just there to steer. Someone had to shovel coal into the boilers, hour after hour, in brutal heat. Someone had to physically load and unload cargo by hand, using ropes, pulleys, and raw human strength. Someone had to constantly monitor the engines, because there was no automated system to do it. Someone had to stand watch at all hours, because there was no radar, no satellite tracking, no computer keeping an eye on other ships nearby. Every single function on that vessel required a human body and a human set of eyes. That's the key thing to understand. For most of maritime history, a ship's crew size wasn't a choice. It was a requirement. The technology of the time simply could not run a ship without dozens, sometimes hundreds, of hands. So what changed? Almost everything. The first major shift came from the engine room. Coal-powered steam engines needed constant manual feeding and monitoring. Diesel engines changed that. They were more efficient, more powerful, and critically, they required far fewer people to operate continuously. As diesel became standard through the 20th century, the small army of stokers and boiler workers simply stopped being necessary. Then came automation of the engine itself. Modern cargo ship engines are now monitored and controlled largely by onboard computer systems. Sensors track oil pressure, temperature, fuel consumption, and mechanical stress in real time. Thousands of readings a minute, and flag problems automatically. A single engineer, sometimes supported by 1 or 2 others, can now oversee machinery that once required an entire engineering department working in shifts around the clock. The engine room used to be full of people. Today, on many ships, it's often empty because it doesn't need anyone standing inside it at all. It runs itself and simply reports to the crew when something needs attention. That single shift alone eliminated dozens of jobs per vessel. The second major shift happened on the deck, and it has nothing to do with the ship itself. It has to do with the box. Before the 1950s, cargo was loose. Sacks, crates, barrels, all different shapes and sizes, loaded by hand, one at a time, by teams of dock workers. This process, called break bulk loading, could take days. It required huge numbers of laborers on the ship and at the port. Then came the standardized shipping container. Once cargo could be packed into identical steel boxes, the loading process transformed completely. Instead of people carrying goods aboard piece by piece, massive cranes could now lift entire containers, already packed, already sealed, directly onto the ship in a matter of minutes. This didn't just speed up loading. It made most of the loading crew unnecessary. The heavy lifting moved from the ship's deck to the port's crane operators. A process that once needed a small army of dock workers on board now needs almost none, because the ship's crew isn't the one doing the loading anymore. The infrastructure on land does it instead. This is a pattern you'll see again and again in this story. Work doesn't just get automated. It gets moved somewhere else entirely, off the ship, onto shore-based systems, satellites, and remote support teams. The third shift happened on the bridge, where the ship is actually steered. For most of history, navigation required someone physically reading stars, charts, and compasses, constantly recalculating position by hand. It required multiple lookouts scanning the horizon in every direction at every hour because there was no other way to detect danger. Now consider what a modern bridge actually has. GPS gives the ship's exact position anywhere on Earth, accurate to a few meters, updated continuously. Radar and AIS, the automatic identification system, track every nearby vessel automatically, flagging potential collision risks well before a human eye ever could. Autopilot systems can hold a precise course for thousands of miles without a hand on the wheel. Weather routing software analyzes ocean and storm data to choose the safest, most fuel-efficient path, recalculating automatically as conditions change. Where a ship once needed 6 or 7 officers rotating through navigation shifts around the clock, modern systems allow that same job to be handled by 2 or 3, because the ship itself is doing a huge share of the monitoring work. The humans aboard are no longer the primary sensors. They're supervisors, reviewing what the system's already detected and stepping in for judgment calls the software can't make. There's a fourth shift, and it might be the most underappreciated one: communication. In the past, once a ship left port, it was essentially cut off from the world for weeks. If something went wrong, the crew had to solve it entirely on their own, with whatever tools and expertise happened to be on board. That isolation doesn't really exist anymore. Modern cargo ships maintain near-constant satellite communication with shore-based operations centers. If an engine sensor detects an abnormal vibration, that data can be transmitted in real time to engineers on land. Sometimes the exact same company that manufactured the engine, who can diagnose the issue remotely and advise the crew on exactly what to do, or whether it can even wait until port. This means the ship no longer needs to carry a specialist for every possible problem. It needs a smaller, highly trained crew who can perform hands-on repairs, while a much larger support network on land handles diagnostics, planning, and expertise the ship itself doesn't need to carry physically anymore. The ship, in a very real sense, is no longer working alone. It's the visible tip of a much larger system. Now, put all 4 of these shifts together: automated engines, containerized cargo, computer-assisted navigation, and constant remote support, and the picture becomes clear. It's not that fewer people are needed because the work got easier. It's that the nature of the work changed entirely. A modern cargo ship crew isn't there to do brute manual labor anymore. They're there to supervise systems, respond to exceptions, perform targeted maintenance, and make judgment calls that still require a human mind. That's a fundamentally different job than what a sailor did 100 years ago, and it explains why it takes so few people to do it. But there's an economic force behind all of this too, and it's worth being honest about it. Crew costs money. Every additional person on board means another salary, another set of living quarters, another mouth to feed for a month-long voyage, another person who needs training and certification. On a global shipping industry that operates on razor-thin margins, where fuel and time are the biggest costs, minimizing crew size isn't just a technical possibility. It's a significant financial incentive. Shipping companies didn't reduce crew size purely because they could. They reduced it because doing so made every voyage measurably cheaper. And in a competitive global industry, cheaper voyages win contracts. So this isn't just a story about clever engineering. It's a story about economics quietly reshaping an entire profession, one sensor, one automated system, one eliminated position at a time. Of course, this raises an obvious question. If ships can run with so few people, why do they still need anyone at all? Why not remove the crew completely? Some companies are actually testing exactly that. Autonomous cargo ships, vessels designed to operate with minimal or even zero crew for parts of a voyage, already exist in early trial form. Short-range autonomous ferries and cargo vessels have completed real voyages using AI-assisted navigation with no one physically steering. But for large-scale international cargo shipping, full autonomy isn't there yet. And for now, a small human crew remains essential, for reasons software still can't fully replace. Machinery breaks in ways sensors don't always predict, and someone still needs to physically diagnose and repair it at sea. Storms, unexpected obstacles, and other ships behaving unpredictably still require human judgment, not just programmed responses. And there are legal and safety requirements. International maritime law still requires certified officers aboard responsible for the ship and everyone connected to it. In other words, the ship isn't crewless because the remaining jobs are the ones automation genuinely struggles to replace. They're the jobs that require adaptability, physical repair, and accountability. Exactly the things machines are still worst at. So the next time you see a photo of an enormous container ship, stacked with what looks like an entire city's worth of goods, remember what's actually happening on board. Somewhere inside that steel giant, a crew of maybe 15 or 20 people is doing what it once took hundreds to accomplish. Not because the work became less important, but because a century of engineering, automation, and global economics quietly rebuilt what running a ship even means. The ship didn't get simpler. It got smarter. And the fewer people it takes to run something this massive, the more it reveals about how much of the modern world now runs, quietly, efficiently, almost invisibly, without most of us ever noticing.